Well, let's do a quick example where we take a couple of sequences, an and bn, where an is defined to be 2n over n plus 1 for all n in natural numbers, and little bn is negative n over n plus 1 for all n in the natural numbers. Well, you probably remember this from calculus. As n goes to infinity, we have n in the denominator. That's going to blow up. So, sorry about that. We've got 2n on top to worry about. This constant is pretty much going to be irrelevant in the limit, this plus 1. And we effectively get 2n over n, which is equal to 2. So it should be pretty easy to see that that an converges to 2. bn, by the same kind of logic, this plus 1 doesn't contribute anything as n gets large, as n goes to infinity. So effectively we have negative n over n, which is just negative 1. So we have bn going to negative 1. I'll say as n goes to infinity. So we suspect that, or we know, I should say, we just proved it as a theorem, that an plus bn is going to converge to a plus b, 2 plus negative 1, which is 1. I'll just write 1 here. Now let's kind of verify that. Let's note that an plus bn for all values of n, I'll just write it down as one single term, it'll be true for all n, is equal to 2n over n plus 1 plus the corresponding term would be negative n over n plus 1, which is, they have the common denominator, so it's simply n over n plus 1. And by similar logic, as we talked about up here, this, as n gets large, this plus 1 becomes less meaningful to the point that it's not meaningful at all in the limit. So this, as we suspected, goes to 1. There's one more quick example maybe I could do that'll introduce the fact that there is an analogous theorem about multiplying the corresponding terms. Well, let's say that an goes to the limit a. A is a real number. Well, that tells us that an plus an goes to a plus a, which is 2a. So another way of saying that is that 2 times every element in the sequence, which is what this is, will go to 2 times the limit of the an sequence. So that's kind of an introduction to what will happen. This will be true for any number, not just 2, and not just an integer. So we'll find that out in a future video.